consider the situation. The frame is made of the same material and has the same cross section everywhere. Calculate the amount of heat flowing per second through a cross section of the bent part if the total heat taken out per second from the end at 100 degrees Celsius is 130 joule. Fine. First of all, we know that dq by dt is given by Ka delta T by L. Alright, now this formula has a similarity with the current electricity that we have studied. The similarity goes like delta T works just like the potential difference between the two ends. dq by dt works just like the current does in current electricity, and this L by Ka works as my resistance. So in all, I call this delta T as thermal voltage, this as thermal current, and this resistance as thermal resistance. Fine. Now with this concept I can solve various problems, any complicated circuit that is given to me. I have a situation like this. Okay, now it is given that heat taken out per second from the end at 100 degree is 130 joule. So thermal current at 100 degree is given to me as, this is the thermal current, is given to me as 130 joules per second. Fine. Now similarly, if this is the thermal current going over here, so some part will be coming from here, let's say Q1, some part will be coming from here, let's say Q2, and Q1 plus Q2 will be equal to 130 joules per second, and over here it will be also 130 joules per second, just like the current electricity. Now the thing is that at point A and point B, fine, we know that the thermal potential difference between point A and B is same, so I can write as that the thermal resistance of this part into the current flowing through this part will be equal to thermal resistance of this part into current flowing from this part. Alright, so what I write is that delta T across AB is same, so I can write dq by dt 1 into R1, that is thermal resistance, is equals to dq by dt2 into R2, that is again the thermal resistance. So just substituting the value, let's say dq by dt1 is x, so thermal resistance of this part will be equal to L, that is total length, that will be 60 plus 5 plus 5, so it will be 70.7 meters, into K into area of cross section, let it be A. Fine. dq by dt2 will be now x plus q2 is equal to 120, so q2 comes out to be 120 minus x, so this will be 120 minus x into length is 60 or 0.6 into Ka, so K is cancelled from both the sides. I have 0.7x is equal to 120 into 0.6x minus 0.6x. On solving this equation, I get the value of x as 60 joules. That is the answer.